The Garrett GTCP 331-350 APU provides an independent source of pneumatic and electrical power that can be used during flight and ground operations. The APU is mounted in a fireproof compartment located in the aircraft tail cone. Access for servicing and maintenance is provided by two doors. The doors are held open by two telescoping rods. The APU is controlled by the electronic control box. The electronic control box is located in the bulk section of the aft cargo compartment. Hello, this is the Garrett GTCP 331-350 APU. It supplies the aircraft pneumatic system with air for engine starting and air conditioning and provides shaft power to drive a 115 kVA generator that supplies the aircraft electrical buses. All component location references are from the rear looking forward. The APU comprises three major sections: the accessory gearbox, the load compressor, and the power section. The power section includes a two-stage centrifugal flow compressor, an annular reverse flow combustion chamber with 12 dual flow fuel nozzles, and a three-stage axial flow turbine. The power section drives the load compressor and the accessory gearbox through a single common shaft. The load compressor has a single-stage centrifugal flow impeller, a diffuser, and a row of inlet guide vanes. The load compressor and power compressor share a common air inlet plenum duct. The accessory gearbox provides support and gear reduction for the accessories and mounting bosses at the 3 and 9 o'clock positions for installation into the aircraft. The accessories include the oil pump unit, the fuel control unit, the starter, the cooling fan, and the APU generator. The APU generator is mounted on the right side of the accessory gearbox. It provides a 115 kVA power supply to the aircraft electrical buses. The electrical power is available throughout the aircraft operating envelope. The starter is mounted on the left side of the accessory gearbox. It is controlled by the electronic control box. The starter is equipped with a brush wear indicator and a manual drive receptacle for maintenance operations. Oil system. Oil servicing is accomplished from the left side of the accessory gearbox. The lower part of the gearbox is the oil reservoir for the lubrication system. The reservoir may be filled through the gravity fill cap or through the pressure fill and overflow connections. A sight gauge verifies the oil quantity. The oil pump unit is mounted on the left side of the accessory gearbox. It provides a mounting flange for the fuel control unit. It includes the oil supply and oil scavenge pump elements. There are three oil pump components located on the right side of the oil pump: the oil pressure relief valve, the oil pressure regulating valve, and the de-oiling valve. The oil pump unit houses two oil filters. One filters the generator scavenge oil, and one filters the oil to the bearings. Both filters are fitted with clog indicators. The pressurized oil is routed to the thermal bypass valve mounted on the air-cooled oil cooler. If the thermal bypass valve is open, the oil is routed back to the oil supply filter. When the thermal bypass valve is closed, the oil flows through the oil cooler and returns to the oil supply filter. Filtered oil is supplied to an oil manifold located on the left side of the APU. The manifold houses an oil pressure switch and and oil temperature sensor. Both line replaceable units are monitored by the electronic control box. Two oil supply lines are connected to the oil manifold. One line supplies the turbine rear bearing compartment, and one line supplies the load compressor and mid bearing compartment. The load compressor front bearing and the gearbox accessories are supplied internally by the gearbox oil manifold. The oil pump unit contains 4 scavenge pump elements. One for the aft bearing sump, one for the mid bearing sump, and 2 for the oil-cooled generator. The aft bearing sump oil is scavenged through an external line from the 6 o'clock position on the turbine case and returned to the oil reservoir. The mid bearing sump oil is scavenged through a line from the 6 o'clock position on the load compressor housing and returned to the oil reservoir. The load compressor front bearing and the upper gearbox oil is returned internally by gravity. The generator scavenge oil temperature is monitored by an internal temperature sensor. The sensor is monitored by the electronic control box. If the generator scavenge oil temperature exceeds a certain threshold, the APU will shut down automatically if the aircraft is on the ground. This sensor is not a line replaceable unit. The scavenge oil is returned through an internal passage to the scavenge filter inlet tube, through the scavenge filter, and into the gearbox reservoir. There are 4 additional line replaceable units located on the accessory gearbox. They are the low oil temperature sensor, the electronic chip detector, the oil heater, and the low oil quantity switch. They are monitored by the electronic control box. The low oil temperature sensor is located on the front lower center of the accessory gearbox. The oil temperature is used to control the de-oil valve. The electronic chip detector is installed at the bottom center of the accessory gearbox. If metal particles are detected, the electronic control box sends a signal to the central maintenance computer. The gearbox reservoir can be drained through the integral drain plug. The oil heater is mounted on the front lower right side of the accessory gearbox. It is controlled by the main APU relay in the APU box. The APU box is located in the aft cargo compartment near the electronic control box. The oil heater is not powered if the APU master switch is in the on position. The low oil quantity switch is located on the bottom right side of the accessory gearbox. If the oil quantity decreases to a low level, the electronic control box sends a low oil level signal to the electronic centralized aircraft monitoring system. The oil system is vented through an air-oil separator located on the front of the accessory gearbox. The oil is returned to the reservoir and the air is vented through a vent line to the APU exhaust. Fuel systems. The APU fuel is supplied from the aircraft fuel tanks. Fuel from the aircraft is delivered to the fuel control unit. The fuel control unit is mounted on the front flange of the oil pump unit. It is driven by a quill shaft from the oil pump. A case drain vents the chamber between the flanges through a one-way check valve. The fuel control unit has 5 main functions: fuel filtering, fuel metering, pressure increasing, servo pressure regulation, and positive fuel shutoff. The fuel control unit supplies the APU with high-pressure metered fuel for combustion and servo fuel for actuator operation. Fuel from the aircraft enters the low-pressure fuel filter. A fuel pressure switch installed at the filter inlet housing is monitored by the electronic control box. If the fuel pressure is low, the electronic control box sends a fuel low pressure signal to the electronic centralized aircraft monitoring system. The low pressure fuel filter is monitored by a clog indicator. To reset it after a maintenance action has been performed, push the red button. The fuel gear pump supplies high-pressure fuel to the fuel control unit. The system is protected by a high-pressure relief valve. Fuel flows internally through the high-pressure fuel filter to the fuel torque motor. The fuel torque motor controls the internal fuel metering valve that supplies fuel to the fuel shutoff solenoid valve. The fuel torque motor and fuel shutoff solenoid valve are controlled by the electronic control box. When the APU is started, the electronic control box opens the fuel solenoid valve and fuel is supplied to two outlet ports. One port supplies high-pressure servo fuel to the inlet guide vane and surge control valve actuators. This fuel is returned to the filter inlet. The other port supplies the fuel flow divider and drain valve assembly located on the left side of the APU. This unit includes a filter, a fuel temperature sensor, a start sequence valve, two fuel manifolds, a fuel flow meter, and primary and secondary drain valves. The electronic control box uses fuel temperature and fuel flow data for fuel scheduling. During the initial start cycle, fuel from the primary manifold is supplied to the 12 dual flow fuel nozzles. When the back pressure increases, the start sequence valve opens and supplies fuel to the secondary manifold for acceleration and on-speed operations. When the electronic control box receives a shutdown signal, it closes the fuel shutoff solenoid valve and fuel flow stops. Then it energizes the ecology drain valve solenoid. High-pressure air from the second stage of the power compressor is stored in the ecology drain accumulator. When the ecology drain valve opens, the air is released through the drain valves. The air flows through the fuel manifolds and evacuates unused fuel to the combustion chamber where it is burned during shutdown. Pneumatic system. Air from the inlet plenum supplies the power section compressor, the load compressor, the APU compartment cooling valve, and the oil cooler. The electronic control box monitors the air inlet pressure through a pressure transducer. The inlet pressure transducer is mounted on the left side of the inlet plenum. It measures the plenum duct pressure. The electronic control box uses this data as an altitude signal. This signal is used for fuel scheduling and to inhibit bleed load valve opening at cruising altitudes. The airflow through the load compressor is controlled by internal inlet guide vanes and the inlet guide vane actuator. The inlet guide vane actuator is located at the 8 o'clock position on the load compressor housing. It's operated by high-pressure servo fuel and is controlled by the electronic control box. The load compressor inlet and outlet temperature and pressure is monitored by the electronic control box. The load compressor inlet temperature sensor is installed at the 7 o'clock position on the load compressor housing. The data is used for fuel flow scheduling, over temperature shutdowns, and reverse airflow detection. The pneumatic manifold located at the 6 o'clock position on the load compressor receives inputs from the load compressor inlet and outlet air offtakes. It supplies the bleed flow sensor assembly. The bleed flow sensor assembly includes the total pressure transducer and the differential pressure transducer. The electrical output signal is used by the electronic control box to control the surge control valve. The load compressor outlet manifold is located on the right side of the APU. The load compressor outlet air offtake supplies a pressure signal to the pneumatic manifold. The pressure signal is used to calculate differential pressure. The load compressor outlet temperature sensor, located at the 3 o'clock position on the load compressor manifold, is monitored by the electronic control box. This data is used to monitor the efficiency of the load compressor. The bleed load valve is installed on the front of the bleed air manifold. It controls the airflow to the aircraft pneumatic system. It is spring-loaded to the closed position. When the electronic control box receives a bleed demand signal, it energizes the bleed valve solenoid. High-pressure air from the first stage of the power section compressor enters the bleed valve actuator, and the bleed valve opens. The bleed valve position is monitored by a bleed valve position switch and a visual position indicator. The surge control valve is installed on the rear of the bleed air manifold. It controls the airflow through the bleed load valve and prevents bleed compressor surge and stalls. It opens during the APU shutdown cycle and vents the excess air to the APU exhaust. The surge control valve actuator is operated by servo fuel from the fuel control unit. The fuel torque motor is controlled by the electronic control box. Air from the inlet plenum is ducted to the gearbox-driven fan. The fan supplies air to the APU compartment cooling valve and to the oil cooler. The compartment cooling valve controls the cooling air flow into the APU compartment. It is pneumatically controlled by a barometric controlled actuator and air from the first stage of the power section compressor. The valve is closed at cruising altitudes. The remaining cooling air is ducted rearward through the oil cooler and exhausted overboard through an air exhaust duct. Recording and indicating. The data memory module is mounted on the left side of the inlet plenum. It stores data specific to the APU. The data is stored in parallel with the electronic control box. This data includes the APU serial number, total operating hours, the number of starts and high oil temperature shutdowns. This data is retained in the event of an electronic control box replacement and will be transmitted to the new electronic control box at the first APU start. The APU RPM is measured by 2 speed sensors. They are installed in the air inlet plenum at the 3 and 9 o'clock positions. They are monitored by the electronic control box. The data is used for fuel scheduling and cockpit display. The exhaust gas temperature is measured by 2 thermocouple rakes installed in the turbine exhaust case. The number 1 rake is on the right side. The number 2 rake is on the left side. Each rake has 2 thermocouples. They are monitored by the electronic control box. The data is used for fuel scheduling, cockpit display, and for over-temperature protection. Ignition. The ignition system is located on the right side of the APU. It includes 2 igniter plugs installed in the turbine exhaust case at the 2 and 5 o'clock positions. The power is supplied by a high-energy ignition exciter mounted on the air inlet plenum at the 3 o'clock position. The ignition system is controlled by the electronic control box. Ignition is active during the start cycle between 7 and 50% of RPM. It is activated during the run cycle if the RPM decreases to 95% to prevent a flameout. Drain system. The APU drain system collects fluids from the fuel control unit, oil pump flange cavity, the inlet guide vane actuator, the surge control valve actuator, and the combustion chamber drain valve. These fluids are drained overboard through a drain mast located at the 6 o'clock position at the rear of the APU. Summary. The APU operation is controlled and monitored by the electronic control box. The electronic control box serves as a maintenance interface with the central maintenance system for fault reporting and troubleshooting operations. The APU is an integral part of the aircraft systems. It enhances the operation of the aircraft by providing an independent source of electrical and pneumatic power that can be used during flight for extended range operations and on the ground, allowing the aircraft to be independent of ground facilities.